So I'm Arjun from Group 1, and the topic that we are presenting on is power infrastructure. So in this case, what power means is mainly electricity for the most part, and it is one of the major backbones of infrastructure that builds a country, makes it developed, pushes its economy forward, and also gives more comfort to the inhabitants of said country. So I will give a quick introduction before my colleagues come and take up the rest of the presentation. So we've seen that electricity is considered to be the key driver for a targeted 8 to 10% of economic growth of India. And it is also very important that we have electricity supply at globally competitive rates, because that would make the country more lucrative for more industries to come and set up, for more FDI to come in, and just make the entire economic growth much more easier and more accelerated. And as we know very well, electricity is required both commercially and domestically. So it's a lot of common sense, but it boosts commercial production, as in if you have a better quality with less fluctuations, and if you can meet the required demand, it is very good for commercial production, and also gives a better quality of life to the general populace. I will next call upon Sudeep to elaborate on the presentation.
India basically. First two parts constitute of power generation, and later is transmission, and last one is power distribution one. Now I will present some values related to this. In India, about 3.44 lakh megawatts of power is generated every year, and it is increasing at the rate of 5.35% in the year of 2017 and 18. Mostly there is a large increase in renewable source of energy. In power transmission sector, it is completely public right now. It is following the rules according to the Central Electricity Authority. And power distribution, it's like interface between power generation and consumers. Now I'll talk about sources of power. The largest source of power is thermal power. Gas and coal constitute the thermal power, and there are other sources like diesel as well. Diesel constitutes less than 1%. Gas and coal constitute about 68% of the thermal complete energy, and they are called as thermal power. And the next highest is hydro, which constitutes about 14%. And later comes the renewable sources, and among them, more than 50% of the other renewable sources, it is wind power. Actually, I'll give a more split about this. Thermal power, as I already said, that more than 68% is thermal power. Among them, there is central, state, and private partnerships as well. Long back, there is only public, but right now, Adani Power, Tata, and Reliance has come into the thermal power, and hence the private partnership has increased to 39%. But the thermal power is non-eco-friendly, so we have to move into the renewable sources as it is an eco-friendly one. But in renewable sources, already the majority is in private sector. Wind power is by Suzlon, and many other companies are holding the wind power stations. In northern and western parts, many public sectors are holding the renewable sources. In southern states, almost 50% and above is held by the private sector itself. And other is solar power. Solar power, even a household can keep solar panels and they can generate the power. Hence, solar power is about 5% of the complete powers. Now, even we have many other sources like tidal energy and all, where we can invest and we can increase the amount of renewable sources of energy. But we need a lot of private investments to do this. So, to talk about private partnerships, Amini will come.
So everyone, we got to know that there are three parts in power: the generation, transmission, and distribution. I'll give a short guideline of like how in each part the private sector is. Coming to the generation, there is an act called Act in Electricity Act, wherein any generation company can establish its own generation station and all without any license. This reduces like major problem. And coming to the transmission part, right now government is looking to sell the successfully running companies in order to generate some funds. They can use these funds in like greenfield projects, or this also increases private investment. they already did some research by planting one PPP in Orissa, and they found that like not opening bidding to everyone, but each bidding company should have some government authority in it, and so that the bidding like cost will not go so low, but it will be like they'll be competitive. And they are also trying to replicate this PPP in transmission sector too, apart from generation and distribution. If we are using it in transmission too, we'll be able to have like power in market, like we can obtain power in market like in competitive prices, so that it will be both beneficial to them and beneficial to the government too. And even they are allowing 100% FDIs also in all the generation, distribution and transmission power sector. So there are more schemes in the power, which my friend will continue.
In order to ensure some private partnerships and to give the power to the people at low cost, government is implementing quite a few schemes. So I have listed some of them. The first one is Deen Dayal Upadhyaya Gram Jyoti Yojana. This one is mainly focusing on the rural areas. The main aspect of this is it separates the agricultural and non-agricultural feeders, and it also focuses on the strengthening of sub-transmission and distribution infrastructure. And the second scheme in that applied in the rural area is Outdoor scheme. It aims in achieving universal household electrification by 2019. It also provides solar-based standalone systems. The next one, Integrated Power Development Scheme, which is focused on rural areas. It mainly concentrates on reducing the losses, mainly the AT&C losses. It aims to reduce the losses to 15%. It also enables the IT strengthening by implementing the IT in this field. Urja is an application that they have provided. Now, in order to improve the private participation in the power sector, a few financial schemes have been introduced. The financial restructuring scheme it is an initiative of Government of India to provide discoms, that is the distribution companies, to achieve their financial requirements. It basically restructures the short-term liabilities. And other one is the National Electricity Fund. It also promotes the investment in distribution sector. Ujjwal Discom Assurance is again a kind of financial assistance for the distribution companies. And one more scheme is Ujala. Ujala is something where government is providing the LEDs so that they can reduce the energy use and reduce the cost of providing electricity. Thank you very much.
Right, fantastic. So first of all, thank you very much. I think you guys hit the main points in that we wanted to talk about, which is essentially what are the kinds of schemes that are in place, what is generally happening in power, all of that. One thing that you did not answer, right, and I'll pose that to you and you can answer now, or you can, and it's not just to this group, any of the groups can answer. You spoke about a certain amount of power that was being generated, right, and you gave a certain figure, but you didn't talk about is that power that's being generated adequate, right? So is the amount of power that's being generated adequate, right? Are we generating enough power? Are we generating less power? Are we generating surplus power that we should give elsewhere? So in general, overall scorecard, I think we aren't generating as much power as we require yet. Of course, if you go back 10 years, 15 years, etc., and you look at the installed capacity, it's gone up considerably, right? So we're doing a lot of work, but we're still not there yet. One of the things is also, one of the things that you want to understand about power is when you produce power, you more or less need to consume it right away, right? So when you generate power, these electrons run and you essentially have to have an appliance on the other end. We haven't really cracked the ability to store power, where you can generate it, store it, transport it, distribute. The only way we can do it is using batteries, and battery technology is of course on the upward swing. But essentially, we haven't really developed these batteries where we can just, whenever power is available, generate power, store it, use it later. So the problem is we have to use power more, in most cases, more or less as soon as we generate it, right? So it's a very dynamic thing. And so what happens is, therefore, there is often an imbalance. There are certain cases where you have a certain amount of power capacity, but the power requirement there is higher. There are also cases where it's the other way around. You have a certain amount of power capacity, installed capacity, the power requirements are lower. So it's very difficult to achieve the perfect balance locally, and therefore you now have these interconnected grids where you are able to actually transport power over longer distances still instantaneously, right? But that's something important to understand about power, is that today, in most cases, more often than not, you need to consume power more or less as soon as you generate it, and that's sort of one of the challenges. I can't generate today for tomorrow's needs necessarily, beyond being able to store it in batteries, right? So that's an important point to think about. All right, other things that some of you would like to add to this presentation that people did not talk about. The grid, interconnectivity of grids is one point. Any other? So smart grid mission is yet another, is one other scheme that's out there. Yeah, what else? This is possibly a slightly more colorful version of the picture that you guys showed, but more or less it's the same thing, right? So let's see. So you essentially have three parts to it. You have generation. All right, this is where power gets generated, but today, when you look at, you guys put up that chart which was quite clear, most of the power is coming from non-renewable sources, right? A lot of our installed capacity is still thermal, some of it is hydro, all of that. These are all static. So thermal power plants, where do you think you would build a thermal power plant? Either near the sources of coal or, well, sources of coal, gas, whatever, or you would probably build it near the coast, and you would probably build it near the coast because you are importing the coal from somewhere, and so as soon as it comes in, it probably makes sense for you to rather than transporting it miles and miles inland, etc., right? So you actually build these facilities. So these are relatively static facilities, they don't move around, and they sort of generate a certain amount of power. There are certain factors like plant load capacity and so on that tell you how efficiently the generation is happening. So what's the installed capacity, what's the production capacity, all of that, right? So you have these large facilities, right? Hundreds of kilowatts, thousands of megawatt size, etc. But because they are far away from the consumers, because this is more of a centralized system rather than a decentralized system, you have one centralized power plant that's actually feeding a vast area. You actually have to build these transmission networks, right, which is part 2. So if generation is part 1, you've got transmission, which is part 2, right? And then so transmission essentially brings it, say, into the city or whatever, and here the Tamil Nadu Electricity Board or the distribution company, which is here, starts distributing it to schools and residences and IIT elsewhere, right? So there are three parts to this, right, which is the distribution. Okay, this is so there's generation, transmission, and distribution, three parts to this. Now there are efficiencies in all of these parts, or inefficiencies in all of these parts. One of the parts where there is a lot of inefficiencies in the transportation, and this is the transmission parts, right? And essentially you have inefficiencies on account of two reasons. One is there are physical inefficiencies, there are the lines are old, there is friction and all of that, and therefore you get a slightly, I'm not an electrical engineer, right, but they could probably tell you a little bit more about this, but generally there are some engineering losses, and possibly you can never completely eliminate those losses because physical systems tend to suffer some kind of loss anyway, right? But those losses, while you may not be able to eliminate them, you might be able to temper them, because if your lines are really, really old and your frictional losses are very, very high, you could install better lines to ensure that you don't lose as much, right? The second component of these losses is theft, right? Power theft, which essentially means there are people who are not connected to the power system, who are not being metered or not paying for power, but who are essentially somehow drawing power from the power lines, either the transmission level or at the distribution level. At the distribution level, it's often one of the best ways of seeing this is if you go right before a festival like Vinayaka Chaturthi or whatever it is, you will find that all the lights in your house are burning a little bit at slightly lower intensities, right? Because somebody is sort of some local community has put in their plugged into that power supply, and they've lit up their huge Ganesha, and as a result of which, right, all our lights and fans. So that's essentially power theft, right, in some ways. So so you have these two losses in transmission, right, which is the point that Chinmay is bringing about, is that we need to do something about this. Now, some time ago, and I don't have figures for this year, right? But what do you think, what percentage of power do you think was being lost in the transmission process, right? So if X units of power are being sent from generation, right? What percentage of that do you think was getting lost? So when I first started teaching this class about 10 years ago, it was about 50%, 40% to 50%, right? So essentially what you're saying is half the amount of power that you're generating disappears, or well, and today it's not half, it's 15%, 20%, etc. So what that means is when you say I have a power deficit and therefore I have to generate more power, perhaps the answer is not in always generating more power. Perhaps by plugging these leaks, you will actually be able to get that extra power that's required. So this is what, and you guys had this, sometimes they're called AT and C losses or AT and D losses, right? Aggregate transmission and distribution losses, aggregate transmission and communication losses, whatever, right? These were about 40%, and of course there are also some inefficiencies locally at the distribution level, right? So one of the schemes, one set of schemes that we've had in the past is to really focus on the aggregate transmission and distribution losses, right? And try to sort of see if we can provide investment to these electricity boards to actually come up with better infrastructure so that they not only have better lines, but they also have better metering infrastructure. So they know, for instance, exactly where the power is going, how much is being generated, all of this. And now it's come down to 15%, which looks great, but possibly can still come down. I mean, you're still losing 1/6 of your power, right, in a power-starved kind of country. So why were we not able to plug these leaks earlier, right? It's not that we didn't know it was 40%, right? People knew it was 40%. Why were electricity boards 10 years ago, 15 years ago not doing anything about it? You know, there are many reasons, but one of the reasons is that the financial condition of these electricity boards was bad. Why is the financial condition of these electricity boards bad? So yeah, revenue is not being generated, power is being sold at a lesser cost. Why is power being sold at a lesser cost? We're all paying for power, right? Right? So there are two parts to it. Yeah, so well, essentially, maybe it's the same part, right? But that's the key word that some of you brought out, which is subsidy, right? So essentially, power is subsidized for many parts of the population, right? So for one constituency of the population, power is virtually free. Which constituency is that? Who gets power for free? Right? So the agricultural sector, right, in many cases power is given for free, right? So you are generating all this power, but you're getting no revenue out of it, and the agricultural sector is huge, right? So there are two problems with regards to that. One is you've got to make up that cost somewhere, right, if you want to be profitable, right? So that means you go to other consumers and you perhaps charge them a higher rate, right? So users like us perhaps don't get charged that higher rate, but although the electricity tariffs have increased in the past, but you go to industry and you charge them a much higher rate. Now the problem with doing that is not all industries might want to pay. Some of them might set up their own generators, right? And as a result of it, you are not necessarily getting money from industrial consumers as well, and the rates that you're charging are probably not large enough to make up for the subsidy that you're giving to the agricultural sector. But the second thing is, if I give you power for free, what is likely to be your tendency? What are you likely to do? You'll waste power, right? Because it doesn't cost you anything, which means there's more and more power that's being generated somewhere that's being wasted in this sector, right? So they're not paying for it, and they're not also efficient at consuming it. And the person who's in charge of this is what we call the state electricity board. So these people, they have costs, right? Because they have to maintain the lines, they have staff, all of that. I mean, they have to run the electricity system. They may not be generating the power, right? That, as you guys have pointed out, could be generated by an NTPC or a Reliance or whoever, right? Anyone can generate, or a Tata Power can generate the power. The electricity boards then are in charge of distributing some of this power, but and so they have costs, but they don't necessarily get the revenues because they're unable to bill their agricultural customers, right? They are billing the domestic customers, but the domestic customers aren't paying that much, and what they're billing the industrial customers doesn't seem to compensate for what they are losing to other sectors that are being subsidized. So if you have, and therefore if you look at their balance sheets, they're all in the negative, right? So they're making losses year on year. They're probably being bailed out by state governments every year. In the budget, you probably give some allocation to the electricity boards for them to top up and keep running. In such a scenario, do you have the ability to invest in new infrastructure, right? There's no money. What are you talking about? In what investment are you talking about? If I had surplus cash, I would invest, right? I don't even have money to run my own operations, right? So where am I going to invest? Okay, so therefore investment doesn't necessarily happen, and therefore these assets continue to degrade, and so frictional losses keep building up year on year. The balance sheets of these organizations start getting worse year on year, right? So this was a big problem that needed to be stopped. At some point, about a decade ago, there was something called the Accelerated Power Reform and Development Program. I think it was called the APDRP, Accelerated Power Development and Reform Program, APDRP. And essentially, it was one of those programs where we said, look, you guys need to professionalize your electricity boards, which means you've got to make them self-sustaining. You've got to sort of, ensure that you don't have debts and all of that. You've got to, probably bring in some new accounting systems, and based on, and if you actually do that, then we will absorb some of your outstanding debt. So we'll bring you to a net zero starting point from which you will actually have to start moving forward. So power sector, while we generate a lot of power, reform is very, very important, particularly in tariffs and also in the subsidy regime and all of that, right? Because if you don't have that functioning, then you're generating a lot of power, a lot of it is getting wasted. The person who's distributing it is bankrupt. They're not able to invest in more power, all of that, right? So those are some of the key aspects of power. All right, a couple of other things I just wanted to touch upon. You guys have talked about this, several different power generation modes, all of that. And one of the things that we'll talk about this briefly is the whole renewable sector, right? Just quick historical note, initially power was private, right? There are a lot of private players generating power. After independence, of course, a lot of it, as we talked about in the last class, there's a whole nationalization movement, all of it became national. And there was really, that's when you had this National Thermal Power Corporation, National Hydropower Corporation, all of this being set up. And then post 91, when we liberalized, we start privatizing sectors, including power, right? So again, there's the question of how do I privatize power? Do I go to a private player and say, you generate, you transmit, and you distribute? Right, and that might be too big an elephant for people to really swallow, right? So essentially they said, let's unbundle power. Let's have distribution and let's have people generate power, just generate power, right? Sorry, we have generation, transmission, distribution, just generate power, transmit power, and distribute power, right? So when you generate power, okay, that's a very simple business model. You are in charge of generating a certain amount of power. You build the power plant, you get the raw material, you generate the power, and you sell it to somebody. Right? And most likely the person you will sell it to is the state electricity board, right, who will buy it from you. So here we have something called a, we have something called a PPA, okay, which stands for Power Purchase Agreement. All right. So essentially what you do, if I'm a private producer, to minimize my risk, is I go to the state government, electricity board, and I say, look, let's sign a power purchase agreement where you guarantee to buy so many units of power at this rate, right? So I am not going to be in a situation where I, generate this power, and we all know power has to be consumed right away, right? But you say, look, I don't need the power. Right, so I don't want to be in that situation. So we'll sign what we call these PPAs, right? So the power producer was called an independent power producer, an IPP, and an IPP would sign a PPA, right? In many cases, all right? And that also worked well because from the government's perspective, you have a fixed, guaranteed supply of power, right? You're not sort of at the mercy of somebody who will give you X units one day, 2X units the third day, X by 3 units the fourth day, because some private fellow somewhere is willing to pay you more. You're also sort of minimizing your risk, right? So this arrangement worked, right? And you can have a competitive bid to figure out who's offering you the best PPA, right? So I can say, I want a 100 megawatt power plant, right? All of you bid and all of you tell me what is the power purchase agreement that you would like, right? All of you are going to give me 100 megawatts of power. You say, I'll give it to you at, 2 rupees a unit, 1.75 rupees a unit, 75 paisa a unit, whatever it is, and I can pick the cheapest person, right? So I can compete, I can pick the most efficient bidder, right? And on top of that, I can have a guaranteed arrangement, right? So it worked relatively well for power generation. There are a lot of power generation that's happening, right? Transmission, right? The problem with transmission, right, is that transmission is what we often call a natural monopoly, right? What that means is there can be 3 different power producers, generators, right? And I could choose to use one of them and the other person could supply to somebody else. That kind of system is okay. But it becomes very difficult to have 3 people laying 3 transmission lines and then me deciding I'll use this person, you deciding I'll use that person. That doesn't really work out, right? So essentially, if you want the economics of the business to work, there can be only one transmission line going from generation to distribution. So it becomes what we call a natural monopoly, right? There's no other way. Naturally, only one person can use. The problem with giving a monopoly out to a private sector is, right, what happens, how do you control prices, right? It's a monopoly, you don't have anybody else to go to, right? And so for a long time, transmission was considered to be something that only the public sector would do, right? That it could not be privatized. Now things are changing. People are saying, let's regulate the pricing, give it out to a private sector because that person can probably maintain it more efficiently, frictional losses will be left. Distribution, it turns out that you can actually have multiple, what people used to call discos, now they're calling discoms, I think, because discos sounds flashy, fun, all of that. So discom probably gives you a better, but essentially it stands for distribution companies. It actually turns out that you can have multiple distribution companies, right? All of whom, and you can actually compete, right? It's like in your mess you have multiple catering options, right? And you can choose one this time, and if you don't like them, you can choose one the next time. But all 3 of them are actually able to survive, right? Because there's enough demand out there that even if you chose to ditch one person and go to the next, somebody else is actually switching the other way around, right? And so therefore the mess example here is not a natural monopoly, much like distribution. You can actually have multiple distributors and you can sort of choose, etc. So distribution, again, there have been some experiments at privatizing. Delhi, I think, tried it for a bit. There's some literature, right? So this is essentially, so privatization is a big part of power, and partly it's there because there is a lot of inefficiency in power generation, right? There are losses in generation, but also a lot of losses in transmission, distribution. And the idea is, can we bring the private sector in because they are more conscious of their profit? They will ensure that they don't lose that much power, right? So there's a lot of privatization coming into power. All right. Most of my other slides are, I mean, just sort of other details on what all of you had, right? So I'm not going to go through all of these, etc. So this slide tells you AT&C losses are to the tune of 40%. The total energy deficit is, there is an energy deficit. We talked about this. The average return on investment for State Electricity Board is minus 26%, which means their balance sheet at the end of the year, when you look at outflows and inflows, right? And all of you know discounted cash flow basics. The return on investment works out to minus 26%, right, on average. Okay, and there isn't enough generation capacity to meet our needs, right? So there's some of this data that all of you brought out. There are a number of schemes. I think you had all of these DDU, JY, Uday, Rajiv Gandhi, Gramin Vidyutikaran Yojana, all of this, right? So you get, and there are probably some more smart grids, all of this, all right? And there are some challenges. We've talked about most of these. One of the big challenges is also that we are dependent currently on coal, right? And unfortunately, while we seem to have a lot of quantity of coal in India, that coal doesn't have particularly high calorific value. So it's not the greatest coal to produce electricity with, and therefore we are actually importing coal from many other parts of the world, Malaysia, Indonesia, and so on. Therefore, we are also at the mercy of things happening outside. So for instance, if they hike the price of the coal that they are selling to us, then obviously the whole power equation goes out of the roof. Okay, so clearly one of the things that we are thinking about is how can we move towards less polluting forms of energy for a number of reasons, right? One is, of course, coal emits quite a bit of carbon dioxide into the atmosphere. Global warming, we want to reduce that. We want to reduce our dependence on coal to make it more environmentally friendly. We also want to reduce our dependence on external international financial markets and commodity markets for our generation. Hydropower is to some extent less greenhouse gas emitting, although it's not necessarily environmentally clean. You might be destroying forests and so on when you build dams. But again, the problem with hydropower is it's normally in places where, as this point says here, it's normally in India's mountainous north and northeast regions. There are a lot of environmental issues, right? Because when you dam a river, you're causing some amount of local flooding, you are damaging people's livelihoods, you're damaging ecosystem, plants, animals, etc. These are also very, very difficult places to construct in. Your cost of construction, all of that is also extremely high. So hydropower has been a big part of our equation, but it's not necessarily the most obvious choice. We've tried nuclear power, which experts will tell you is perfectly safe, etc. But try telling that to the people who are living next to the nuclear power plant. right, and you get a different story. So nuclear power is always very contentious. People always go back to Chernobyl and this and that and talk about disaster. So then we come to things like wind and solar, right? So which again we are now starting to tap. Now the thing with wind and solar is right now solar energy is abundant, right? And as somebody sort of once said, actually everything that we're consuming, all energy forms are essentially solar energy. So when you look at coal is energy, so is essentially solar energy over millions of years has actually baked earth into and crushed it into coal. So it's essentially solar energy that's been stored over millions of years, which we are in some ways unleashing. So the potential for solar energy is huge, and solar energy, the amount of energy that is emitted by the sun is enough to meet all of our needs and more, right? So there is no energy credit. The problem is how good are we today at capturing that energy? Right? Because essentially the technology today is you have these photovoltaic panels where you have these elements that are inherently unstable, right? Photon from the sun hits it, you have negative and positive essentially dispersing, and then you can create a circuit so that the negative goes and reaches the positive and you get power, right? So that's the idea. If you can do that really efficiently, right, you can generate a lot of power. So today our photovoltaic systems, the efficiency is continually improving. As it improves, the cost comes down. Right? And also as we manufacture more and more panels to scale, the costs will come down. So the costs are, 5 years ago it was, I think, exorbitant, right? Today it's not exorbitant anymore. The hope is that going forward, particularly countries like India where we are blessed with enough and more sunshine, in fact sometimes we wish we could export some of the sunshine to gloomy places like the UK, etc. So that's one resource that we are not lacking in, should really be able to leverage. So I think solar and wind, and there's some talk about tidal energy and so on, I'm not too familiar with where that's going, are alternative forms of energy that we're looking at. Now in solar, some of you might know some of the work that we're doing at IIT, Professor Ashok Jhunjhunwala and his group, and that's quite interesting to discuss in this context because everything we talked about here is centralized. Large power plant in the center, produce a large amount of energy that a lot of people need, right, and transmits it and distributes it all over the place, right? What the group here at IIT is trying to do is flip it on its head and say, why don't we do a decentralized model, right? Why do you have to have a huge asset that generates power from everybody, for everybody? Why can't we just generate the power that we need locally, right? So essentially, and this is what you see in the rooftop solar kind of installations, but essentially the idea is you put a small panel on the roof, that small panel generates a small amount of electricity. That electricity is not necessarily for anybody else but can use to run some of your functions. So it can be used to heat a little bit of water so you can have a nice hot water bath. Although why anyone in Chennai will want a hot water bath, I've never understood, okay? But you can do things like that, and of course if there is surplus energy, electricity, you can export it back to the grid, and maybe you can earn money, right? Because when you put it back into the grid, it's going somewhere, somebody else is using it, right? So in some ways you're selling money to someone else. So maybe you can get some money out of it, and if you supply it during peak hours, then maybe you can get more money out of it because people will be willing to pay more. So there's sort of this model. So there's this decentralized model, right, that is evolving particularly with regards to solar. Yeah, Arjun. Yeah, so decentralized solar is sort of relatively well known. The innovation that the group here is working on is also saying, so one of the reasons for the inefficiency, and I'm not an authority on this, but it goes back to the old, Edison and Tekla wars, right, about 100 years ago on what was better, alternating current or direct current, and all of those kinds of, Tekla was on one side, Edison was on one side, and Edison founded General Electric. He had more muscle, Tekla didn't. So you guys can go back and read the history, but we came to a point where we said, look, we are actually going to transfer current through the alternating current mechanism, right, because that works well for transmission over long distances, and therefore all our appliances, right, will be AC appliances, right? So most of these appliances here probably run on alternating current. But what happens when you generate power is you often generate it as direct current, you convert it into alternating current, and you send it out, and there are all these sort of losses. So what the group here is doing is you generate direct current, right, and then you actually put in appliances that take direct current, which are different from these appliances, right? So then you can actually have a much more efficient system, so you can essentially run your televisions, your air conditioner, etc. on much less power, right, than you did earlier. So in other words, earlier with the decentralized solar, you could run lights and fans. Now if you go to Research Park ground floor, there's actually a demo of how you can, they actually have an LED TV, they have I think an air conditioner, I think they have a fridge, or they're going to sort of develop a fridge, whatever. So, and this is very, very useful in parts of rural India where you don't have connectivity. So if I want to buy a refrigerator today, I have only Kelvinator or whoever only gives me a Godrej, I don't know, Whirlpool, I guess, I don't know who manufactures refrigerators these days. Give you refrigerators that work on alternating current, for which you need AC supply, for which you need to be connected to the grid. If I'm a poor village in Rajasthan, where do I get that connectivity, right? Whereas now if I have a refrigerator that runs on direct current, I have a solar panel on my roof and I can translate that directly into direct current and connect it to my refrigerator, then all of us, and then people in rural Rajasthan or wherever it is can actually have power, right? So one of the things that's happening is that we are not only investing in centralized power generation, we are also investing in decentralized power generation, right? So this, in other words, is the scorecard, right? There is a lot of power that's being generated. We need more power. There are lots of inefficiencies, and we're doing a number of things about it to reduce transmission and distribution losses, more generation capacity, try looking at decentralized, looking at alternate power for, power sources. So lots of things are going along. But the problem has not been solved yet, right? We are not one of those states where we have a smooth running power infrastructure that we don't have to do anything about. All right. So that essentially is a quick whirlwind overview of power. Power also needs to be regulated. So you have electricity regulation boards, primarily because you have private players coming in charging tariffs. So there's a regulator in power as well. All right. And there's something called ultra mega power projects that was there some time ago, essentially where the government said, look, let's try to build large generation capacity. We'll sort of get land clearances, all of that. So that was a scheme that took off. Right. So there are a number of other schemes that was out there. All right. All right. So we'll stop with power and we'll move to telecom. And so group 2, where's group 2?